Given the Boolean variables P, Q and R, how does the truth table of P or Q or R look like? How can you even construct it? You saw how to construct a truth table for two variables, right? It was very easy. Take simply two variables P and Q, assign P to be 0, Q to be 0, P to be 0, Q to be 1, 1, 0, 1, 1. Only 4 lines and you are through. You would have written all possibilities. But when you have 3 variables, you got to do a little more work. What is that? Write all possible values that P, Q, R can take. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. Totally, you are going to get 8 lines here. Why is that? If you don't know the answer for this, you probably should revise back your counting chapter, right? It's a very obvious reason here. How many possible 3-digit binary numbers can you think of? 8. 2 to the 3, right? That's why you have 8 entries. Okay, so how do we compute P or Q or R? The idea of OR is one of them should be true. So, is one of them true here? 0, 0, 0? None of them are true. So, this is going to be 0. Remember how the R table looked like in 2 variables? In 3 variables, it's going to be very similar. If you spot a 1 anywhere, you must call that as true. So, I see a 1 here in the second line, 0, 0, 1. So, it's a 1. I see a 1 here. So, it's a 1. Everything else is a 1 for the obvious reason that you will spot a 1 somewhere. So, the truth table of P or Q or R will have all 1s except for the first entry where P, Q, R are all zeros and hence the R of P, Q and R will be 0.